Okay, so today we're going to talk about privacy, mainly. So, this is the basic problem we have. We have lots of people online, and they all somehow send their data to big companies, and the companies do more or less whatever they want with the data. They have some terms and conditions, you don't know what they are. But you get something out of it, yeah? It's not like you get nothing. So you get what your friends like, you get news, you get nice advertisements for stuff you want to buy, things like that. So maybe it's actually useful, but you are giving them something. So you are the product in some sense, right? So they're buying something from you. They're buying your data. And it's actually worth a lot to them because of advertising, because they pay advertising money for them, for your data, so they can target advertisements and make money. So that's the basic idea of social media, actually, as a business model anyway. Yeah. And the question is, can we, let's say we accept some amount of privacy loss by giving our data, right? Because we like the service, then what can we actually guarantee about privacy loss in this case? Yeah. Can we guarantee anything at all? How much do we trust this service? Yeah. How do we send the data to the service? What is the service allowed to do with the data in order to guarantee some kind of privacy? Yeah, these are all kind of important questions, but they're not. This is not like the first time that issues like this arose. Okay, so even before these big data, internet, social networks, we had lots of other privacy issues. Whenever there was some public signal or some publication of private data, yeah? And some things that might appear innocuous are actually sometimes privacy destroying when you do them. Okay, and I will go through a few examples of that. Okay, but I assume that some of you have already seen problems where the data you have at a company is, let's say, your data, but someone hacks into this company and they steal the data. Okay, we're not dealing with this problem here. Okay, if you have given your data to a company and you agree there's no other bad actor that will kind of take your data away. So we're kind of talking about legitimate uses of the data in a way that you have already agreed with the company. Okay. Okay. So in statistics in general, we have two problems. We want to analyze data of people. Okay, this data might be very sensitive, like health information, drug use, stuff like that. And we want to publish something about it. Why? Because we want the health authorities to know what are the health problems, right? And we would like the public to know as well, right? So everybody should know. But you cannot just do that. Take all the data and just publish it and say, oh, analyze my data, analyze everybody's data. You cannot do that, right? People don't want to share the data with everybody. Yeah? You can try and anonymize the data, so you can hide people's names and stuff, but still that doesn't help. We'll see some examples here, okay? This is not about cryptography. This is a completely different subject. So if I am trusting Facebook with my data, then I can have a fully cryptographic channel between me and Facebook, so that any data sent to Facebook is not intercepted by anybody else, or the data that Facebook keeps are guaranteed to be there forever. Nobody can steal them. The FBI cannot see them. They don't have a way to do it. Okay, assume that everything is correctly implemented. So nobody can actually do anything with the data. That's between me and Facebook. And Facebook can do some things that we agree that they can do. But it's not about cryptography. Cryptography is a different problem. The problem we have is that whenever Facebook has some data, they do something with this, right? They say to the advertiser, okay, you might be interested in buying a bicycle. Okay, that seems okay, but maybe they say, okay, you are interested in buying a pregnancy test kit, okay, for example. Why? I don't know. Yeah. So this is actually something that happened. There was this supermarket company in the US, and suddenly the house started getting advertising leaflets for new moms and pregnancy things, and the father realized that his daughter was pregnant, was actually a teenager, I think. So, well, she probably didn't want to be discovered that she was pregnant, for example. Anyway, so this stuff can happen, okay? This is all an issue of trust in the end. So who do we trust with our data? How much do we trust them, okay? And then what data do we give them? And then also how much do we get out of it ourselves? So if you get a lot, then maybe you can sacrifice more privacy. So if I'm participating in a medical trial about curing my incurable disease, maybe I will say, okay, I have this disease and this is my genome, please help me, okay? Potentially have a lot to gain, but I cannot just give my genome to everybody and say, I have this disease, and I don't want to give it maybe to my insurance company in the US at least, because then they would make me pay more money, okay? So there is this trade-off. And now this issue of trust, this is something that we don't deal with here either, because it's a kind of a social contract between the people and the service. So you have to decide yourself how much you are willing to sacrifice privacy. And quantifying this is a bit difficult, okay? Because there's a formal way to define privacy loss, but actually quantifying it is kind of difficult. So it's usually on the hand of the service provider to really put a good trade-off between making the service useful and maximizing privacy. Yeah. And then this creates other problems, like how do you verify that they're doing it correctly? Things like that. Again, we cannot go into that here because this is a big research topic and it's not solved. I don't think it will ever be completely solved. But yeah. Okay, so we start with a very simple example before we go into anything about privacy. Just to remind people that what is database, unless you all know databases already. So, great. Yeah. Okay. So let's say you have a typical tax office database, okay? So typically you have some ID, like in Sweden you have this ID number. I guess it's the same in Norway more or less. You have your name and maybe they have some record of your salary and how much money you have overall in the country, age and postcode, okay, something like that. Now, there are basically two database access models that you might want to think about. One is what happens when you actually have the data yourself. You can just go and look at the data somehow. You don't have to think about a query language, so to speak. But let's say that there's a tax database somewhere, and I have a computer, and I want to say, well, hello, can I get the number of people that live in this place and have more than 1 million in the bank? Okay. Now the database server might refuse the request, for example. It might not allow the connection at all. But let's say I have this authorization, and I can do it. Okay. So, but I don't really have actually the data, but I can actually do any query I like. So this is the query model for databases. It has been very successful. Okay, I'm not a database guy, by the way. Martin, who was here earlier, he is a database guy. He has a class about database. So how does it work? Let's say you have your database system right there, and you have a Python program that you write, and the Python program connects to the database in a magic way, which you don't even have to know anything about. And it asks a query, and the query could be something like, how many people named Donald Trump are in the database? And it gets a response, 5, 100. Okay. And that's it, basically. It's very simple. It's like you have some accountant and you ask him what is, to tell you statistics about the data. Or it can actually give you complete data rows, or the complete database. Maybe he will do that as well. Okay, so this is language called SQL, which I forgot what it means. I guess it means something query language. Does anybody know? No? Okay, fine. We don't care. So it has basically one statement that's important to us. And it's called select. Okay? And select basically says, well, I want to see these columns from a table. So you have names for these columns, like name and salary. And if you do that, then you will get back the whole database, these two columns. Okay? And this one will just return everything in the database. if you want, you can also select specific roles. So if I want to select people that have a salary of 150,000, I would just run this thing, select every row from the table where the column value has its value. And you can do even more complicated things. You can count points of the table where some condition is satisfied, like this one. Average, sum, or anything like you want. So there are not so many functions, but there are quite a few. So you can do basic counting queries. That's one of the things that people would like. So how many people over the age of 50 have lung cancer in the state of California? If you had this database, then you could do this query. Okay? The basic idea is okay? Okay. So let's go through a quick example. I have a quick example somewhere. So let me just find it. Okay. So this one I will probably go to 2. Okay. I'm kind of losing my screen here. Here it is. Okay. Okay, that works. Okay, that works. Fine, okay. Okay, so the first thing that we want to do maybe is to see how we create our database. Okay, this is basically the example that is in the Python tutorial, so it's not something complicated. So there is a module called SQLite3 in Python, and this allows you to do stuff like that. So the first thing that we do is create a new database. It might exist already or it might not. Okay. So let's, in this case, let us remove it. It already exists. It doesn't. Now the first thing you do is you create a cursor. Basically, this cursor just points to a record in the database. If you imagine that you are looking at this table here, yeah, you can say, well, I'm at this record now, and the cursor is just a row in the database. Yeah. So you can move it up and down, but normally you don't really use it in this way. Okay. So now we create a table, and the table is like this one, and in this case it's a stocks table. So you have you enter transactions in stocks. So where you when you did something, what the transaction was, what you bought or sold, how much you did buy or sell, and at what price. It's a table like this. And so anytime you want to actually run a command of SQL using SQLite, you just use this cursor and execute the command. And one way to add data is the insert command. Okay? So it uses this table. You can have many tables, right? Not just one. So one table could be stocks, the other could be options, another thing could be accounts, you know, lots of things. And you basically add the row to the table, specifying everything there on the list. And then you commit the changes and it's finished. So just run it. No. So now we're done, and there should be a file here called example. There it is. Okay. So that's good. And let's see something else now. Now we can do the same thing to access the database. Open the same database, right? Now we can add more things at the same time. So you can have this command called execute many. It lets you add many transactions at the same time. Okay? Great. So now you add these particular buys into your ledger. Yeah. And now this is the interesting one. So now after you have done this, you can select a specific thing from this table. Okay. So in this particular, I want to select everything in the stocks table where the symbol is equal to the value RHAT. I guess it's red hat. Yeah. So let's try it now. Python. Python 3 database access. Yeah. So that was the first thing that we added. Yeah, that was we added this one before. Get this line out. Okay. So it's pretty simple, and you can also run things like get the average price of something. Let me just run it again. So let's see. I didn't read the print before, but basically I can get the average price for all the stocks where the symbol was IBM, right? And here the average is basically 49. So it likes those two parts of the table, yeah, because it matches symbol IBM and it calculates the average price. Okay, so it's pretty simple, right? So that's all you need to know about SQL in this class, right? You don't need to know anything else. How it works, I don't know. Okay, but you can execute these very simple commands. And the nice thing about the model is you don't really have to have a database, it can be somewhere else, right? You just ask something and you get a reply back. And the server can decide if they want to answer the query or not. They can say, I don't want to answer this query, it's too big, for example. Yeah. So that's nice, you have extra security, you don't really have problems with that. Okay, now think about it a little bit. Let's go back to presentation. Okay. Now I want to talk about privacy database, okay? Yeah. You might have some other database, okay? But it's not in the database. People might not want to know what's in their Tinder database. Okay? And you might have birthday, no name, postcode, stuff like that. Okay? The names might not be real, for example. But you have various statistics, because this is what people care about, and some other data. Okay, so, one thing you can do to actually hide the data of people is to just hide their names, right? And then people don't know who anybody is, right? Just anonymous. Anybody disagree? You disagree?
Disagree with like if you have knowledge about them, like if I knew everything about you and your height and everything, I could just go through everything and say, oh, that's you and name that's
correct. Yeah. So you have some side information, like specific knowledge about me, right? Yeah, that's fine. Yeah, that's good. That's exactly the problem. Yeah. So an adversary could have a lot of other information, right, about you, and you can use that to break privacy. Okay. So this was an actual example from the 90s. There was voter information in the city of Cambridge, Massachusetts. So basically, name, address, registration, party, last vote, and postcode, birthday, and sex. Okay, not a lot of information, but it was public. You can pay $5 or something, and you get a floppy disk. It was old days. So you get a floppy disk with the data. And then another database was out there, medical database about specific disease, and they wrote all these things. Okay, and now you see that some things are in common. Okay, and we could do what is called linkage, data linkage. It's actually a common operation in SQL that exists. It's called join. So you can join databases. So in this case, you could do a fuzzy join of some sort, and that means you can identify, like, with certainty, like, I don't know, like 90% of people in this data set. So it's very, very kind of interesting. Of course, people, when they publish this data, they didn't think about, okay, what happens if we publish this data? What if somebody knows inside information? Yeah, they didn't think about it. And even if you thought about it, it's not clear how you solve this. Yeah? Because it might be useful to know where the person is. Because maybe there is some, let's say, mineral in the water or toxic mineral in the water in some area, and then you see people that have this disease in that area. Maybe there is some link to something environmental, or the sex, or how old they are. So that is useful, right? It's not completely useless. Yeah. So the question is, how do you deal with that? Okay. How do you do that? Okay. So one of the first answers to that was k-anonymity. K-anonymity is kind of interesting. It basically tells you that if you have a database, then and the database contains some identifying characteristics. Now, what those are is not clear. You have to decide what they are yourself. But let's say everything can be identified to make it easy. Then no k people can be differentiated from each other. So at least if you have one person who has these characteristics, then there are at least k minus 1 people with the same characteristics. Now, in the data we had before, it was not the case. It was only 3 records. Of course, everybody was different, right? So the problem is that you have some database that you originally created, and then you anonymize it by using this concept. And this at least protects you against being able to identify a specific person in the database. At least a little bit, but not completely. Okay? I'll just give an example for that. So this is not to say that this is the best concept of privacy. K-anonymity, I'm just saying it's one of the first rigorous concepts, and it's easy to apply, but the guarantees it provides are very weak. Okay? But still, it's better than just anonymizing, removing the names. So now you have 5 people, and you can add, well, every person is unique, so it's what's called one anonymity. Yeah. If you just remove the name, it doesn't help because still these are uniquely identified rows. So if you know everything else, you know what the name is. Okay, you remove the profession, it still doesn't help so much, so you also make the postcode a bit fuzzier, so let's say it starts with 1 or 6. So it still identifies the area, but not give a precise postcode. So now you have, I guess, still one anonymity, because there's one guy here that is different from everybody else, right? Okay, so now we remove the birthday and just have this. And, well, this is not clear. So, yeah, this should be wrong, actually. I should also change this one to be the same as before. Okay, almost correct. So it's not wrong, it's wrong this way. But anyway, if we fix this, so we can make it so there are at least 2 records that are the same. So if we remove this record here in the middle, yeah, then it will basically work. So we have to anonymity. Now the problem with actually doing k-anonymity is that the optimal way of doing it is a little bit hard, but you can have various approximations. So one idea is to say, well, you can give me ideas actually. So, let's say I have a database. A database, what is a database? It's a set of points, right? In some space. And you want to make sure that you want to split the set into neighborhoods. So that every neighborhood contains at least k people, right? So can you give me a simple algorithm for that? Think about it. It doesn't have to be very clever, okay? Because a simple algorithm actually is pretty good in this case.
Men altså sånn, altså i stedet for å si at høyden er 1,85 og 1,86, altså 14, sånn at man er mellom 1,80 og 1,90. Ja, på en måte.
Man har på en måte flyttet det til et felles punkt.
Ja. I'm not sure if it's get it correct, but like our idea is that we loop through every person, and then you look at say person 1, person 2, and you find say like the height up there. If the first person was 185 and the other one was 186, you sort of expand it to an interval.
Yeah.
And then you just go and do that for every person. So he's a member of one of the groups with 8 people. Sort of. I'm not sure if that's correct, but yeah.
Yeah, that's one of the first algorithms actually. That's what they did.
Yeah.
So, yeah, it's very simple, right?
Yeah.
Yeah, so that's great. Yeah, that's fine. I mean, if you know you want k-anonymity and you have n records, then you basically need to split the data into n divided by k parts, right? So let's say you need to split the data in 3 parts, like here. I will wait. Let's say you need to split the data in 3 parts. Can you see it? Okay, great. Well, okay, one way to do it is basically you select a center, like one guy, like you said, and another center here, and another center here. And then you don't want to start growing the one guy only, because that doesn't work. And you just get everything. So you grow one guy around, let's say get the neighborhood, okay? And then you grow the other guy around some neighborhood, and then the other guy too, okay? And then you can continue growing, and then it will kind of work, because you're sure that at least everybody will get at least k people there. Yeah. It will still probably be inefficient. You'll probably end up with a neighborhood like this, for example. So maybe not the best possible neighborhood, because some people will be far away. So it will be one neighborhood like this one, and then another neighborhood like this one, and one more like this. So it's not very well distributed, but you don't really want to play this game too much and waste time. But that would be the basic idea of how you do k-anonymity. There's another way that you can do this that's very efficient. Remember we mentioned KD tree at some point, okay? So there's a way to split data or a universe of data, and it's called the KD tree. And why is it called a tree? Let's say you have some data. Okay, that's kind of very regular here, but doesn't matter. So the basic idea is you look at the data, select one of the 2 dimensions, like here's the height, here's the age, okay? You look at the average, or the median actually, and you select the guy in the median. Now you partition the data in 2 parts. One is the people on the right, and one is the people on the left. Now you do the same for this guy now. Pick the median of this dimension. Okay, so you split the data like this, okay, and then this guy only has 3 people, so you split like this maybe, and so on. So then you get a tree now where the lower level nodes are very small, contain only a little 1 or 2 people, and actually want to stop at k people. So we don't want to have more than less than k people in every node, and the tree will look kind of like this, okay. And here we can stop. So here is all the data, and then here is half the data, and half, here half and half, and so on. But we are guaranteed to have half and half, because every time we click the median. Yeah. So half the people are going to be less than this person. So this works nicely. Just it's not the most efficient way to do it in a high dimensional space. For a high dimensional space, there's another idea called a cover tree. It is pretty interesting. Why? Because it guarantees, I will not explain the algorithm, I'll just say that it guarantees that if 2 people are siblings in a tree, then they are close enough to be siblings, or far away to be siblings, and the parents are always guaranteed to be close enough to their children. And in particular, if you arrange the tree into levels, level k plus 1, okay, then these guys have to be 2 to the minus k minus 1 far away, and they have to be at least 2 to the minus k close to their parent. So the further you go down the tree, the closer things are together, but always you maintain that there is always a clear separation between siblings, so they're not, so you put siblings far enough apart so that the clusters are separated, but you also make sure that they are close to their parents. So if you write it like, if this is the top node, then you will have 2 children that are not very close to each other, yeah, but they are still close in some sense to their parent. And you would like this to hold for every node that you create in the tree. Okay, so this is a very, very well-known algorithm, cover tree. It's one of the first algorithms that is actually a useful algorithm for creating a neighborhood tree. So you can use it also to make a very efficient k-nearest neighbor implementation. Yeah. If you remember k-nearest neighbor, to find the k-nearest neighbor, you have to go through everything in the list and do a sort. If you have this type of tree, then you basically only need to execute the logarithmic number of comparisons, because the depth of the tree is logarithmic in the size of the data. Okay, so this is kind of a tangential thing about the algorithm part. I thought maybe it was interesting to know about. Okay, and then after the break, we'll talk about another concept in privacy. It's much stronger than k-anonymity, differential privacy. And this is going to be also tomorrow's topic. So we're just going to have a very brief introduction today. Yeah. If you want now, you can stay to discuss something, but otherwise I'll take a break for 15 minutes.